Hey guys, I'm not going to keep you long. I was just going to run through this example really fast for you. So lesson 5.5 is not really introducing any new material. Yay! It's just pausing and making sure that you know how to apply all the material you have learned. And how are you going to apply it? Well, look at the very top of this section there. It says when you use a function as a mathematical model, you must be able to calculate y when x is known and be able to calculate x when y is known. So y when x is known is pretty easy, even in a quadratic. But x when y is known is a little bit harder. So we're going to practice that. So our objective, we love our blue letters, given the equation of a quadratic function, be able to calculate the value of y for a known value of x and the values of x for a known value of y. Most of the time you'll have 2, right, in a quadratic because it's a second degree polynomial. Okay, so if f of x equals 3x squared plus 2x minus 11, find f of negative 4. Y'all can all do that in your sleep. You just plug negative 4 in every time you see an x and you get the answer eventually of 29. Okay? But B, find x if f of x equals negative 6 is different. Okay? So this time, instead of substituting in negative 4 for your x, you have to substitute in negative 6 for your f of x, which is really just your y, right? So flipping over on the page to 196, you see that you're going to sub in that f of x right there as negative 6. So now we have negative 6 equals 3x plus squared plus 2x minus 11. So you cannot get an answer quite yet, but look, if you just transform this, of course what you've done there is add 6 to both sides, and then they've just flipped the sides around so you can see it a little bit more clearly. But 3x squared plus 2x minus 5 is because they've added this 6 over here and here. And when they added it over here, they got minus 5, right? Negative 11 plus 6 is 5. And it's negative 5. So then they just switch the sides of the equation because it's prettier for the 0 to be over on the right. Okay. So then they've just used the quadratic formula, right? And we love the quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And, of course, in that, this is your a, this is your b, this is your c. And really, guys, the quadratic formula is not pretty. It's not elegant, but it's right, and it will get the right answer every time. So you just solve it just like you have. They simplified it down to here. Negative 2 plus or minus the square root of 64 over 6. Square root of 64 is 8. Negative 2 plus 8 would be 6 over 6. So that would give you the 1. Negative 2 minus 8 would be negative 10 over 6, which would give you negative 5/3. So these look just like our x-intercepts. They're not. They're our x values at the f of x or y value of negative 6. Okay? So they're solved the same way we solve for x-intercepts. It's just that now we're saying the whole thing equal to negative 6 instead of equal to 0. So this equation said find the values of x, not solve the equation. It's not necessary to write the answer as a solution set. Okay, so you can just write 1 or when x equals 1 or x equals negative 5/3. You don't have to put it in a little set with its y value, but whatever. Okay, and then it says, as you recall, an x-intercept is the value of x when y equals 0. So you're going to do the exact same thing you just did, that you've been doing in lesson 5.3 and 5.4, and find the x-intercepts, which is the exact same solution deal up here, except for you're finding the x when f of x equals 0, right? What is an x-intercept? It's the value of the graph when the y value is 0, when it crosses the y-axis. Or crosses the x-axis, when it crosses the x-axis, because the y value is 0, that's what an x-intercept is. And so only difference between up here and up here is here it's crossing the y value of negative 6. So the horizontal line at negative 6, it crosses it twice, once at 1 and once at negative 5/3. So now we have the horizontal line of 0, which will be the x-axis. So that's what happens when y equals 0. Okay, So read through example 2 and make sure you understand it. And then look here, this is important. Since the discriminant is positive, there are real values for x for which f of x equals -5. Do you remember those tips back here? They're very important. Trust me, you're going to want to know them for your quiz. And they are, I think, in 5 point, let's see if I can find it. Yes. They are on page 184. Y'all learned that blue box. If b squared minus 4ac is negative, okay, so what is b squared minus 4ac? It's the determinant, right? If it's negative, it's, yeah, the discriminant. I'm saying determinant. Oh, I'm tired. It's the discriminant, okay? So if the discriminant is negative, the equation has imaginary numbers. If the discriminant is positive, the equation has real number solutions. If the discriminant is a perfect square and a, b, and c are rational numbers, then the solutions are also rational numbers. Okay, so 5.5 is not super hard. It's not any new information. It's the same information, just making sure that you understand how to do it and what to do to figure it all out. So do your homework and text me or call me with questions, or class reach or group me, or all the ways. Have a good night.